Okay, so when you're working this function, you're trying to find all the roots of it, and I give you 3 minus 2 root 2. You have to remember that in giving you one of them, I'm also giving you the other, 3 plus 2 root 2. Okay, so we know we have 4 roots, and I've given you 2. What we want to do is we want to do synthetic division with the root that we're given to try and find the rest. Okay, so I'm going to write 3 minus 2 root 2, although if you wanted to, you could do 3 plus 2 root 2 first. It's just whatever you choose. And then just make sure when you write these out, you leave some space in between. 9, negative 42, 5, negative 396, and 68. Okay, so we're going to do synthetic division. So process is drop the first number, multiply. 9 times 3 is 27, and 9 times negative 2 root 2 is negative 18 root 2. Negative 42 plus 27 is going to be a negative 15, because that's going to be 27, 50, yeah. So negative 15 minus 18 root 2. And then we're going to multiply this times this. So, hey guys, I did say you could talk, but let's keep it down a little bit. Okay, so when we multiply these two, it is a binomial times a binomial, which means you're going to need to write it out to the side and distribute. Okay, so we distribute. 3 times negative 15 is negative 45. 3 times negative 18 root 2, so 30 and 24, so negative 54 square roots of 2. Now we multiply or distribute the negative 2 root 2. Negative 2 root 2 times negative 15 is a positive 30 root 2. And negative 2 root 2 times negative 18 root 2. A negative times a negative is positive. 2 times 18 is 36. And then just remember, negative 2 root 2 times negative 18 root 2. You've got a positive 36 times 2, which is a 72. And then we add those together. So negative 45 plus 72, or 72 minus 45. We've got 25 to get to 70, and then 27. So 27 and then negative 24 root 2. So that's my answer when I multiply this times this. So my answer goes underneath the 5. So 27 minus 24 root 2. If you're worried about things getting mixed up, you can draw vertical lines to kind of separate your expressions. Okay, so we combine and we're left with 32 minus 24 root 2. And then we multiply again. I need to multiply 3 minus 2 root 2 times 32 minus 24 root 2. So 3 minus 2 root 2 times 32 minus 24 root 2. We multiply 3 times 32 and get 96. 3 times negative 24 is negative 72 root 2. Negative 2 root 2 times 32 is a negative 64 root 2. And negative 2 root 2 times negative 24 root 2. Negative 2 times negative 24 is 48, and then times 2, because square root of 2 times square root of 2 is 2. So 48 times 2 is another 96. Add them together. We get 1,292 and 136 square roots of 2. So we put this times this, goes here, and that answer is 192 minus 136 square roots of 2. We add negative 396 plus 92, or subtract, is negative 204 minus 136 square roots of 2. So one thing to know is remember that the second time is always going to be easy, so this is the last time we have to distribute out the binomial times the binomial. 3 minus 2 root 2 times negative 204 minus 136 square roots of 2. 3 times 204 is 612, so negative 612. 3 times negative 136 would be 390 and 18, so negative 408 square roots of 2. 390 is 18, yeah, okay. And then this is a positive 408 square roots of 2, 2 times 204. And then negative 2 root 2 times negative 136 root 2. So negative 2 root 2 times negative 136 root 2 is 272 times 2, which is 540 544. 544. Add those together. These two will go away. Sorry, that was out of view. And 544 to 600 is 56, and 56 plus 12. 56 plus 12 is 68, and that's a negative, so negative 68, which is good. All right. So the next step is to divide out the other root, which is 3 plus 2 root 2. We'll go ahead and do that. Okay, and we drop. 9 times 3 is 27, and 9 times 2 root 2 is 18 root 2. Those two cancel each other out, and we're left with 27 minus 15, which is 12. All right, now we multiply. 12 times 3 is 36, and 12 times 2 root 2 is 24 root 2. Those two go away, and I'm left with 68. 68 times 3, well, that's 180 plus 24, so 204. And 68 times 2 is 136, so plus 136 square roots of 2, remainder 0. Which means that when I divide this quartic by 2 roots, I'm left with a quadratic. 9x squared plus 12x plus 68 equals 0. So we have to solve this quadratic for the remaining roots. So I'm going to say x equals negative 12 plus and minus the square root of 144 minus 4 times 9 times 68 over 18. And when you type the interior of the radical inside, inside the calculator, you get negative 12 plus and minus the square root of negative 2,304 divided by 18. And in fact, if you type in the square root of 2304, you get 48. Let me make sure that was, yeah, that was it. Okay, so this is negative 12 plus and minus 48i over 18, and 12, 18, and 48 all divided by 6. So my final answer for this is negative 2 plus and minus 8i all over 3. My final answer for the problem is my roots are 3 plus and minus 2 root 2, and negative 2 plus or minus 8i all over 3. So that is one way to work this problem with all that multiplication, which is kind of satisfactory whenever you work it all the way out. I will say though, if it hadn't been the 3, if it hadn't been the binomial, it would have been a lot easier. When you just have the one term, distributing is not nearly a big deal. As big a deal. Okay, but in the other option, you have long division. So if you're going to work it using long division, then what you would do is you would multiply out your two factors, given the roots, given x equals 3 minus 2 root 2. You know the factors are x minus 3 minus 2 root 2 and x minus 3 plus 2 root 2. So we multiply. X times x is x squared. X times negative 3 is negative 3x. X times negative, or 2 root 2 is 2 root 2x. We've got negative 3x, positive 9, minus 6 root 2, minus 2 root 2x, plus 6 root 2. And negative 2 root 2 times positive 2 root 2 is a negative 2 times positive 2, negative 4. And then root 2 times root 2 is 2, so negative 4 times 2 is negative 8. So this quadratic is x squared minus 6x plus 1, which means that instead of dividing out each of these individually, I could just divide out this quadratic at one time, and I should end up with this answer right here. So let's practice that quick. I've got x squared minus 6x plus 1 divided into my original polynomial, 9x to the 4th minus 42x cubed plus 5x squared minus 396x plus 68. And so we ask ourselves, what do I need to multiply x squared by to get 9x to the 4th? And that's going to be a 9x squared. 9x squared times x squared is 9x to the 4th. 9x squared times negative 6x is a negative 54x cubed. 9x squared times 1 is 9x squared. And then we subtract. So minus, plus, minus. Those go away, and I'm left with 54 minus 42 is 12. 5 minus 9 is negative 4. And then drop the negative 396. So then you ask yourself, what do I need to multiply x squared by to get 12x cubed? And that is a 12x. 12x times x squared is 12x cubed. 12x times negative 6x is a negative 72x squared. 12x times 1 is a 12x. And then we subtract. So minus, plus, minus. Those go away, and I'm left with 68x squared minus 408x plus 68. And if you do that last multiplication, x squared times 68 will give me 68x squared. So 68x squared, 68 times negative 6 is negative 408x, and 68 times 1 is 68, so that when we subtract, you're left with the remainder 0. Okay, so if you were working this problem starting here, then you would have started doing this, you would have multiplied it out and got this, you would have done the long division, and then what you get is this is what this times this will give me the original, right? So you would still have to solve 9x squared plus 12x plus 68 equals 0. So you would use the quadratic formula like we did up there. Okay? So all in one kind of snapshot, both processes. You've got your synthetic division. You've got all this multiplication. Wait till it adjusts. You got all this multiplication, and you can do them individually. It's always the first one that's a lot of work. The second one is pretty easy. And you get down to remainder 0. You're left with the quadratic. You solve. Long division, you multiply out the factors. Put them in factor form, multiply them out, and then use long division with that. What you got when you multiplied them out. And then you got to solve. Okay, so that's the first problem, and let's do the other one. Okay, so I would pause the video so you can write that problem down. Okay, when you're working this problem right here, first off, you ask yourself how many roots do you have, and you have 6. I'm giving you, in fact, 2 roots, negative 5 plus I, which means also negative 5 minus I. But there are 6 roots in total, so the first thing I would suggest you do is graph it. If you graph it, then you can see if there are any rational roots, and there's going to have to be. I can't give you 6. So if there are 6 roots, 1, 2, 3, that's not 6. And 2 are imaginary. Yeah? Then the other 4 can't all be imaginary or irrational, because then I haven't showed you a way to solve for those. So what you would have to assume is that maybe 2 more of them are irrational or imaginary, which means the other 2 could be rational. So maybe these 2 are rational. But you won't know until you graph. Okay? So if you do graph this function, which I think I have it typed in. Yeah. So if you graph it, you get something like this. So that one looks like 2. I'm going to zoom in on this one. I'm going to go from 0 to 3. And that looks a lot like 1/2, and I think this crosses at 2. Okay. So we're going to go ahead and think 1/2 and 2. Yeah? All right. At this point, you could go ahead and divide this one out first, but it might be easier to just go ahead and do the rational one so you have a lot less to multiply. As far as like which one you do first, it's completely up to you. I think I'm going to go ahead and do the 2 first. So I've got 8, 60, 20, negative 410, 216, negative 220, and 104. All right, here we go. Drop the 8, multiply by 2, 16, multiply by 2, 76, multiply by 2, 152, multiply by 2, or sorry, add 172, multiply by 2, 344. Yeah, okay. Add and I get 5676, negative 76. Let's see, just make sure. 4 tens, no, 66. Because 56, yeah, okay. 66 times 2 is negative 132. So 68 plus 16, so 474. So 74, that's 148. And if I'm wrong, I'll figure it out somewhere. Okay. 148, so that's 52, negative 72. Yeah, something's wrong. I'll probably already know what it is. Okay. 8, 60, 20, negative 410, 216, negative 21, 4, 76, 140 plus 12, 152, 172, 200, 140. Negative 410 plus 344 times 2. Gosh, it's 84. The 21 minus 13 is 8. Jennifer, I'm fired. Okay. Oh, something was wrong. Alright, so 2 times 84 is 168. So 168, that's 32 away from, so 32, 52, so negative 52. Yeah, that makes sense. And then negative 104, remainder 0. All right, so now, negative 66 and 84. All right, let's divide out 1/2 now. So drop the 8, half of that is 4, add 80, half of that is 40, add 212. Yeah. Yep, okay, half of that is 106. Add that and you get 40. Half of that is 20. Half of that is 100, or adding them together you get 104. Half of that is 52 and remainder 0. So don't forget that we were doing synthetic division with a fraction, which means you have to divide. So we're going to divide out by 2. So 4, 20, 106, 20, and 52. Alright, now we're going to do the synthetic division with the imaginary root that I gave you at the beginning. Negative 5 plus I. Okay, I have to do my scratch work over here. So I'm going to drop the 4. 4 times negative, I might not need it though. 4 times negative 5 is negative 20, and 4 times I is 4I. If I add these, I get 4I. Negative 20 and 4I. Okay, alright. Oh no, Jennifer. That would have been bad. I was going to say, I don't remember that simplifying. Okay. So 20 plus 4I. So then negative 5 plus I times 20 plus 4I. And then as you multiply, you get negative 100 minus 20I plus 20I. I times 4I is 4I squared, and I squared is negative 1, so negative 4. Those two cancel each other out, so we're left with negative 104. So we'll just put negative 104. Add, and I get 2. 2 times negative 5 is negative 10, and 2 times I is 2I. So I've got 10 plus 2I. So I'm going to multiply negative 5 plus I times 10 plus 2I. That's negative 50, negative 10I, plus 10I, and then I times 2I is 2I squared, or negative 2. This adds up to negative 52. Remainder 0. Okay, now we need to do the other root, negative 5 minus I. Drop the 4. 4 times negative 5 minus I is negative 20 minus 4I. So negative 20 minus 4I, which all cancels out, give me a 0. 0 times all of that is 0. Add them together and I get 2. 2 times negative 5 is negative 10, and 2 times negative I is negative 2I. Remainder 0. So at that point, I'm left with a quadratic 4x squared plus 0x plus 2 equals 0. And you're trying to solve. So I would subtract the 2, divide by 4, it's negative 1/2. Take the square root, x equals plus or minus the square root of negative 1/2. Take the I out, plus or minus the square root of 1/2 I. If you want to simplify that, you can. You could say the square root of 1 over the square root of 2 is 1 over the square root of 2, which equals the square root of 2 over 2. I would accept that. I would accept 1 over the square root of 2. I would accept the square root of 1/2, as long as you have the I as well. So x equals 2 1/2 negative 5 plus and minus I, and plus and minus the square root of 1/2 I. And there's all your roots. Okay, just to reiterate, we could work at this point. I would obviously always do this first. Okay, do synthetic division with rational roots first, and then with this right here, this quartic. Let's see, I had a power of 6, and then I had a power of 6, and then I divided out 2 of these rational ones. I could do long division with 4x to the 4th plus 40x cubed plus 106x squared plus 20 plus 52. But the question is, what would you be divided by? And so what would you would want to say is, okay, so instead of dividing each of these individually, we would divide by the product of their factors. Sorry, I just wrote that out. You can see what I was writing. I was writing out this quartic that was left over after I divided by 2 roots. Okay, so I'm going to use this space right here to multiply out my 2, or put these in factored form. X, it's a negative 5 in both cases, so x plus 5 plus I, and x plus 5 minus I. Okay, we multiply these out, we get x squared plus 5x minus xi plus 5x plus 25 minus 5i plus xi plus 5i. And then I times negative I is a negative I squared. I squared is a negative 1 already, so it's a negative 1, which is a plus 1. So this right here equals x squared plus 10x plus 26. So if we divide this quartic by these 2 at the same time, then we should end up with this quadratic. So let's test it. Whoop. What do I need to multiply x squared by to get 4x to the 4th? And that is a 4x squared. So 4x squared times x squared is 4x to the 4th. 4x squared times 10x is a 40x cubed. 4x squared times 26 is, let's see, 80 plus 24, so 104. All right. Then we subtract. So minus, minus, minus. It becomes 0x cubed. I'm going to go ahead and write down this one, even though we never write that one down because I need that placeholder. Plus 2x squared plus 20, I forgot my x. 20. Alright, I need to multiply x squared times 0, x. to get 0x cubed. So I'm just gonna 0x cubed plus 0x squared, and you can skip this step if you want to and just go ahead and move on to the next one. But the idea being that we go from here, and then plus 52. So what do I need to multiply? Let's see. X squared by to get 2x squared, and that's a 2. 2 times x squared is 2x squared. 2 times 10x is 20x, and 2 times 26 is 52. Subtract, and remainder 0. So you can see how, instead of dividing them out individually, one at a time, and I got 4x squared plus 2, I did long division at one time with both, and I got 4x squared plus 2. I would then need to solve that and find all my roots. But that's how I would do that. Okay.